Hello. In this video, we'll be talking about different ways to take the derivative for MAC2233, Calculus for Business and Social Sciences. We've already talked about product rule, quotient rule, and chain rule. These will be kind of the special ones. So we're going to talk about how to take the derivative of log and natural log. So we have some examples here. So let's say we wanted to take the derivative of natural log of x squared plus 1. Well, you can see that where they come from is up here in the notes, but the example would be we do 1 over the original, whatever you're taking the log of, and then take the derivative of whatever you're taking the natural log of. So for this example, the derivative of natural log x squared plus 1 would be 1 over x squared plus 1 times the derivative of whatever you're taking the natural log of. So the derivative of x squared would be 2x, the derivative of 1 would be 0. So the derivative would be 1 over x squared plus 1 times 2x, which if we do 1 times 2x would be 2x over x squared plus 1. Okay? That's for natural log. Now, how do we take a derivative of a log? Well, remember logs have different bases, so we'll have to take that into account. So if we had log base 2 of x cubed plus x, then we would do 1 over whatever we're taking the log of, x cubed plus x, in parentheses, times the natural log of the base, which in this case is 2, times the derivative of whatever you're taking the log of. So the derivative of x cubed is 3x squared, and the derivative of 1x is 1. So in review, how do you take the derivative of a log? You do 1 over whatever you're taking the log of, in this case it's x cubed plus x, in parentheses, times, still in the denominator, the natural log of the base, which in this case is 2, times whatever you're taking the log of, the derivative of whatever you're taking the log of. So the derivative of x cubed is 3x squared, the derivative of 1x is 1. So in the numerator we would have 3x squared plus 1, and in the denominator we'd have x cubed plus x, in parentheses, times the natural log of 2. So, in reviewing, when taking the derivative of a natural log or a log, kind of the same thing. 1 over whatever you're taking the natural log or log of, times the derivative of whatever you're taking the natural log or log of. But don't forget, if it has a base, like log base 2, we put ln of whatever the base is in the denominator. So a couple more examples. If I want to take the derivative of natural log of 3x to the 5th plus 4x, it would be 1 over 3x to the 5th plus 4x, times, and we keep everything in parentheses, the derivative of whatever you're taking the natural log of, 15 x to the 4, because the derivative of 3x to the 5th, 5 times 3 is 15, 5 minus 1 is 4, plus the derivative of 4x is 4. So in the numerator, we'd have 15x to the 4 plus 4, and in the denominator, 3x to the 5th plus 4x. In the next example, to take the derivative of log base 5 of 6x squared minus 3x plus 2, remember the log has a base, we have to deal with that. So it's 1 over the original, whatever you're taking the log of, 6x squared minus 3x plus 2, in parentheses, natural log of 5 for the base, times the derivative of whatever you're taking the log of, derivative of 6x squared is 12x, derivative of minus 3x is minus 3, derivative of 2 is 0. So in the numerator, 12x minus 3, and the denominator, 6x squared plus 3x, minus 3x plus 2, in parentheses, ln of 5. So, what if we add a little bit to this? For example, if I want to take the derivative of natural log of square root of x plus 1, how would I do that? Well, remember, if we can rewrite it to make it easier, we should. So remember, the square root is the same thing as being raised to the half. So we have the ln of x plus 1 raised to the 1/2. So, to do this, we're going to follow what we learned about natural logs, but we may have to incorporate something else. So, how do we take a derivative of a natural log? 1 over whatever you're taking the natural log of, times the derivative of it. Now, to take the derivative of x plus 1 raised to the 1/2, we need chain rule. So the 1/2 would go in front, keep the original x plus 1, 1/2 minus 1 is negative 1/2, times the derivative of the inside, derivative of 1x is 1, derivative of 1 is 0. And then a couple different ways of simplifying, but first of all, this would be the derivative. Now to simplify, remember, raising to the negative 1/2, if we move it to the denominator, would be raising to the positive 1/2. And another way to write x plus 1 to the 1/2 is square root of x plus 1. Then square root of x plus 1 times square root of x plus 1 is kind of like square root of x plus 1 squared. So when you square a square root, you're left with just x plus 1. And then 1 times 2 is a half, which we can write as 1 over 2. You can distribute the 2 to the x plus 1, and your final answer will be 1 over 2x plus 2. Again, this can be a little complicated, but we did natural log derivative with chain rule inside of it. Be careful how you simplify. Okay, so here's another one. What if I had something like the natural log of 1 plus x plus the natural log of 2 minus x? How would I deal with it? Well, because they're being added, we would treat them separately. So to take the derivative of natural log of 1 over x, it's 1 over 1 plus x, times the derivative of 1 is 0, derivative of 1x is 1, so the left side would be 1 over 1 plus x, plus, to take the derivative of natural log of 2 minus x, you do 1 over 2 minus x times the derivative. Derivative of 2 is 0, derivative of negative 1x is negative 1, so 1 times negative 1 would be negative 1, so your final answer could be 1 over 1 plus x plus negative 1 over 2 minus x. So again, be careful as we do the rules and use other rules with it. Now, if we had absolute values for a natural log, we take the derivative the same way. So if I had the natural log of absolute value of x cubed plus x, and I want to take the derivative, it would still be 1 over whatever you're taking the natural log of, x cubed plus x, times the derivative of the inside, which would be 3x squared plus 1. So the answer would be 3x squared plus 1 on top over x cubed plus x. Same thing for log. Again, it has absolute value, but with the derivative, we treat it the same way. So the derivative of log base 5 absolute value of x squared plus 1 would be 1 over x squared plus 1 in parentheses, ln of 5 for the base, times the derivative of the inside, derivative of x squared plus 1, derivative of x squared is 2x, derivative of 1 is 0, so 1 times 2x would be 2x over, in parentheses, x squared plus 1, ln of 5. Now, when we want to take two other special cases, taking the derivative of an e or taking the derivative of a number raised to a variable, how would we do that? So in this example, we're taking the derivative of e raised to the x squared plus 1. So the steps are, number 1, rewrite it, so e to the x squared plus 1, then take the derivative of the exponent. So the derivative of x squared plus 1, derivative of x squared would be 2x, derivative of 1 would be 0. So to review, how do you take the derivative of an e? Step 1, rewrite it. Step 2, derivative of the exponent. And then you can put the 2x in front, so it would be 2x e to the x squared plus 1. So our first example of this one, if I had e to the x squared minus x plus 1, how would we take a derivative of an e? Step 1, rewrite it. E to the x squared minus x plus 1 times, make sure it's in parentheses, derivative of the exponent. Derivative of x squared is 2x. Derivative of negative x is negative 1. And the derivative of 1 is 0, so your final answer would be in parentheses 2x minus 1 times e to the x squared minus x plus 1. Now, how do we take a derivative of a number raised to a variable? Number raised to a variable such as 2 raised to the 3x. Okay? 3 steps. Step 1, rewrite it. 2 raised to the 3x. 2 is the base, so kind of like we did with logs, we'd have to put times ln of the base, which in this case is 2. And then we take the derivative of the exponent. Derivative of 3x is 3. So in review, what the steps are is how do you take a derivative of a number raised to a variable? Step 1, rewrite it. In this case, 2 raised to 3x times ln of the base, which is 2, times the derivative of the exponent, which is 3. And that could be your final answer. So another one of those, if we had 3 raised to the x squared minus x, step 1, rewrite it. 3x squared minus x times ln of the base, which in this case is 3, times the derivative of the exponent, derivative of x squared minus x, derivative of x squared is 2x, derivative of minus x is minus 1 in parentheses. Then we'll do some application problems. Thank you.